Right now, University Medicine and Medical Science Lab faculties. General Chemistry, Lecture 1. The importance of chemistry. Chemistry is a science about chemicals. Chemicals are all the day-to-day things you touch, see, and smell. Your body is composed of chemicals. Everything that surrounds you, including this paper and air, are the air you are breathing. Chemistry is that branch of science dealing with the study of matter, its properties, uses, and the different changes that it undergoes. Matter. All the chemicals that make up your world are examples of matter, whether they be found in pencils, books, stones, people, etc. We can define matter. Matter is anything that has a mass and occupies spaces, volume. Examples of matter are wood, water, air, iron, coal, and sulfur. Chemicals. Chemicals are everywhere. Many chemicals occur naturally in the world around us or are produced by living things, rocks and sands, oil, gold, silver and copper, cotton, and wool, sugar, and salt. These are some examples of materials composed of chemicals that humans have used for ages to build shelter, make clothing, and feed themselves. Then we can define chemistry as an important part of chemistry is the study of chemical reaction. Chemical reactions are changes that occur when chemicals interact with others to form new and entirely different substances. Measurements. We can measure length, volume, and mass, which is weight, of matter in either the English or metric system. But we prefer the metric system because of its greater ease in handling and is more frequently used in scientific work. The following table shows those two types or two types to show the two units. Here we have three units: length and volume and weight. We have column one, the middle column English system, and on the right we have the metric system. The length in English system we can use inch, foot, and yard. Metric system we can use millimeter, centimeter, and meter. The volume in English system we can use cubic inch, cubic foot. In metric system we can cubic centimeter or liter, etc. Weight, ounce, pound, and ton. This is in English system, but in metric system we have to gram or kilograms. You have fundamental and derived units. The fundamental units used to express the fundamental quantities which are not expressed in any other form, e.g., mass. An example: mass, and length, and time, etc. Derived units which are expressed in terms of fundamental units. Example: area, volume, speed, and so on. System of units. The foot and pound and second foot. This is an English one. We have centimeter and gram and second. We call it CGS. We have meter, kilogram, and second. We call it MKS. Modified form of MKA system in which beside meter, kilogram, and second, Kelvin, candela, ampere, and mole are also used to express temperature, luminous intensity, electric current, and quantity of matter. International system of units. We have basic physical quantities. They are 7. These are basic. We have length and mass and time and electric current and temperature, and luminous intensity and amount of substance. Or we have name of S1 unit and symbol of S1 units. Meter, we use length, we use meter M. Mass, kilogram, kg. Time, second S. Electric current, ampere A. Temperature, Kelvin, K. Luminous intensity, candela, CD. And amount of substance, mole, EMOL. Mass. Mass is the amount of matter in an object. This amount of matter for an object is constant. Weight. What is the measure of the force with which an object of a given mass is attracted by gravity? Unlike mass, the weight of an object is not constant. It can depend quite strongly on where the object is located. For example, on the moon, the gravitational attraction is only about 1/6 as great as on Earth. Mass is measured in units of grams or kilograms when the mass is very large. Properties of matter. Properties are the way a chemical substance looks and behaves. Describing a sample of matter, we specified its characteristics or properties. For example, we might note its physical state, which means we would specify whether it is a solid, a liquid, or a gas, or might also specify its mass. Properties of matter continues. The properties of matter can be divided into various broad categories, which are extensive and intensive properties. Extensive properties. An extensive property, it is one that depends on the size of the sample being studied. Example of an extensive properties are mass and volume. As the size of the sample increases, so does its mass and volume. Intensive properties. An intensive property, it is one that is independent of the size of the sample. Some examples are physical state, color, melting point, and boiling point. For example, all samples of pure copper are solid at room temperature have characteristic colors that you would surely recognize and melt at temperature of 183 degrees centigrade.